Hi, welcome to LeetCode. In this video, I am going to discuss LeetCode problem 1780. Check if number is a sum of powers of 3. So given an integer n, return true if it is possible to represent n as the sum of distinct powers of 3. Distinct powers of 3. Otherwise, return false. So distinct power means for this example 1, the n is equal to 12. So you can see that we can actually represent this 12 by this 3 to the power 1 plus 3 to the power 2. So 3 to the power 1 means 3 plus 3 to the power 2 means 9. So ultimately we actually sum is 12. So here actually also mention that the power should be distinct. Here actually 1 and 2. There is no repetition. So if it is possible to represent our n in different power of 3, then we will return true, else we will return false. So what actually we can do? So brute force approach will be, suppose we can actually to represent n, we actually need maximum power is power maximum is 15. Okay, so what I will do, I will check that if a car 3 to the power 15 it is greater than equals to n, then we will take this 3 to the power 15. Then actually I will subtract this. Okay, this is the suppose new n1. So I will check 3 to the power 14. It is greater than equals to n means the n1. Then actually we will take this 3 to the power 14. So ultimately we have to reach the n is equal to 0. If it is possible, then we will return true, else we will return false. Correct. So this is the iterative approach. So we will check from largest power to the smallest power. So we will start from power is equal to 15 to 0. Okay, so I'll check that 3 to the power 15, if it is greater than equals to or less than equal to n, then we will take this. If it is greater than n, so it is possible to take no. Suppose our 3 to the power 3 to the power 10 is something x, and our current number is 1000. Suppose if x is greater than 1000, can I actually take this in our representation of power of 3? No, because it is already exceeding the total sum. We have to actually uh, equalize the sum, right? It always the sum should be 12 or n. So that's why I will check that if our current power is less than equal to n, then actually we will try to take this, and ultimately if we reach any n is equal to 0, that means we actually able to um, represent this n, the input n, into the power of 3 with distinct power. Correct. Then we return true. So now go to select code. So just see the yes. So what will do? I'll just start from a power is equal to 15 to 0. I minus minus. I have to lower. So I'll check the current value is 3 to the power I. If it is x, suppose it is x. If our current n value is greater than equals to x, so I will take this x. So 3 to the power I will take into our representation. So what will do? I will subtract n minus x from the n, and this will be the new n for the next time. So if we somehow reached n is equal to 0, that means we are able to represent the n in 3 to the power of 3 with distinct power, then we return true, and if we're not able to represent, then return false. Clear? Now, so this is the one approach. Another approach, we can actually use recursion here. How? Similar, because we are actually iterative. They're actually iterative. So here what we'll do, we'll start from power is equal to 0 and n, right? So I will check that 3 to the power 0 is less than equal to n. Then we will take this. So n will be n minus 3 to the power 0. Correct? So there, and if we already reached n is equal to 0, 0, that means we are able to represent this then we will return true. Okay, this is one base case, that if we are able to reach 0, that means we actually able to represent this with the power of 3. Next is, if our 3 to the power I or 3 to the power, yes, 3 to the power I is greater than n, that means we are not able to find any valid representation, so we return false here. Got it? These two are the base cases. So if we have reached the n is equal to 0, that means we are able to represent in power of 3, we return true. If our current power 3 to the power I is greater than n, so should I go to 3 to the power I plus 1? No, because if we're not able to represent with 3 to the power I, then how is it possible to represent 3 to the power I plus 1? Not possible, so I return from here false. Okay, so this is the base case. Next is, what is the, we will take current power, or will not take. There are two option. We'll take the current power, means we will consider n minus 3 to the power I, or I will pass this next power. Will not take the current power. N will be same. These are two possibility. So I'll check that if in this two path, if in one path actually got the true means we are able to represent the our input number n into power of 3, then we will return true. Right? So I'll take the OR value. So now go to the code, then it will be more easy. So here I have taken a helper function and passing the current power is 0, starting from 0, 3 to the power 0, and the current number is n that I have to represent in power of 3. Now I will get, so ultimately this helper function will get two things. One is the power, current power, and n. So I'll check that if n is equal to 0, that means we actually able to represent the input number in the power of 3. So I'll return true here. So this is one base case. Another base case is that if our current power value 3 to the power is greater than n, so we will not able to take this current power and also the future one, because the power will be more, power value will be more 3 to the power I. Whatever the value actually 3 to the power I, that will be less than the 3 to the power I plus 1. So that's why return from here actually false. Else there are two options. One will, I will take the current power, or will not take. So if we add the current power, so what will do? I will actually go to the next. I am calling the helper function again. I am passing the power plus 1. This is okay. I am calling the next power plus 1. Means it is starting from 0. Now next power will be 1. Then it will be 2 in this way. But if we add the current power, if we take the current power, then what will be the next n value? That will be subtracted, because we have added the current power into the representation. So that's why n minus power of 3 to the power. Got it? And if there another option is that we can actually skip the current power, so that time our helper function will pass in the next power plus 1, but our n is also same. Got it? N is also same because we are not taking the current power, so that's our n value is still same. So in any one of this path we are getting true, so I have to return true, right? So that's why I'm taking the OR value. It is clear? So I have actually shared this code in the description. You will check that. So thank you. See you in the next video.